Hello guys and welcome to another science lesson. This is our second science lesson on states of matter. Now last lesson we were looking at our solids, our liquids and gases, but this lesson we are just going to focus on our gases, okay? So examples of our gases, that's oxygen, things that we breathe in, and usually gases we can't actually see them, so it'll be quite interesting to investigate them today. Now our aim is I want you to investigate the gases and explain their properties. Success criteria, I want you to identify the solids, liquids and gases, explain some uses of gases, and maybe even for some children to investigate the weight of a gas. Okay, so here is a bottle of fizzy lemonade. Which states of matter can you identify in the materials that make up the whole bottle of fizzy drink? So I suggest that you, with a piece of paper and a pencil, you could even draw out this bottle of lemonade, and I want you to label the different parts of this bottle, whether they are solid, whether they are liquid, and whether they are gases. And then we can come back together and then we can see which parts that you identified. Okay, so pause. Right, so hopefully you have drawn your bottle of lemonade and you have labelled each of the parts, either a solid, liquid or a gas. So let's see. Which of these materials and states of matter did you identify? So first, the plastic lid. The top of a lemonade bottle, that is a solid. Next, the actual plastic bottle. That is a solid. So the container that it is in, solid. As this is a fizzy drink, so a fizzy lemonade, the bubbles inside the drink, that is a gas. The paper label on the outside, so we can easily say it's a lemonade, that is a solid. The actual drink of lemonade, that is a liquid. Okay, so the bubbles of gas. So what are the bubbles in fizzy drinks made of, and why are the bubbles in fizzy drinks, and how are the fizzy drinks made? So I can click on each of these bubbles by each question and read the short fact file to find the answers to these questions. So what are the bubbles in fizzy drinks made out of? Let's find out. So the bubbles in fizzy drinks are made from a gas called carbon dioxide. Now carbon dioxide is a gas that is all around us. It makes up only about 0.04% of the Earth's atmosphere, which isn't a right lot. So carbon dioxide, when we breathe in oxygen, and then when we breathe out, we actually produce carbon dioxide. And the things that then breathe in carbon dioxide, that is actually trees and plants. So that is why it's really important that we look after our planet and look after the trees, because they then breathe in carbon dioxide and they breathe out oxygen, meaning that we have fresher air all the time. So why are there bubbles in fizzy drinks? Well, let's find out. Oh, so who invented the first fizzy drink? In 1767, a clergyman and scientist called Joseph Priestley accidentally invented the first fizzy drink. He found a way to dissolve gas in water, making the first soda water, or carbonated water. When he drank the fizzy water, he described a peculiar satisfaction. I must say, I really do like a fizzy drink, so I'm very thankful of Joseph Priestley. So let's find out, how are fizzy drinks made? Well, if I'm thinking of the first bit, so carbon dioxide, and then this person, Joseph Priestley, put something inside of the fizzy drinks, I think it might be something to do with carbon dioxide, but let's find out. So fizzy drinks are made by adding carbon dioxide to liquid under huge pressure. The carbon dioxide dissolves in the liquid and settles in the space above the liquid in the bottle or can. So when the container is opened, the pressure decreases and the gas escapes quickly, making a hissing sound. The bubbles appear as the carbon dioxide turns into gas. Also, just like when we open a Diet Coke can, whenever you just crack the lid, it goes shh. That is all the carbon dioxide escaping. And then when we see the bubbles in a fizzy drink, that is the carbon dioxide turning into gas. Quite interesting. So let's see what's next. So carbon dioxide, as well as making our drinks fizzy, it actually can be quite useful. Some fire extinguishers use carbon dioxide to cool flames and to stop oxygen getting into the fire. Carbon dioxide freezes at minus 78 degrees Celsius and it becomes a solid called dry ice. It is used to transport foods that needs to be kept cool and fresh, such as on aeroplanes and trains, and as you have read, carbon dioxide is dissolved in water to create fizzy drinks. Very interesting. So now, do gases weigh anything? So these children are talking about the weight of gas. So in a moment I'm going to ask you to pause it and we're going to see whether you agree or disagree with any of these people below. So the first one says, gases are lighter than air, so they do not weigh anything. Gas has no weight because it is invisible. And then finally, a gas does have weight because it is a material. So on your piece of paper, you could put this as number 1 in the red, number 2 as blue, and then number 3 as the yellow, and put whether you think this is true or false for each of these. So maybe just put a T or an F. Are they true and false? And then after you've got that, come back to me and then we can explore and see whether these are true or false. Okay, pause. Right, well, let's find out. So we're going to actually watch this film to see some children thinking about this question by wondering about whether the bubbles of gas in a fizzy drink affect its weight. Let's find out. Does gas weigh anything?
Which weighs more, fizzy lemonade or flat lemonade? It's obvious. Flat lemonade weighs more. Fizzy pop's got air in it and air makes it lighter.
Okay. This glass of fizzy pop weighs 173.1 grams.
You see all those bubbles? They make it lighter. Shake it and it'll go flat.
Careful, don't spill any.
Right, it's nearly flat now. Wait again, it'll be heavier.
172.6 grams. It weighs less now.
Why is the fizzy pop heavier than the flat pop?
It's easy to think of gases being totally light, even weightless, but gases have mass like everything else. The bubbles of gas in lemonade don't weigh much, but they do weigh something. So once the gas has escaped, the lemonade will be lighter. The gas in fizzy drinks is carbon dioxide.
These balloons are filled with a gas called helium. It's much lighter than air. But these balloons are full of carbon dioxide, which, as you can see, is a heavy gas, much heavier than air.
Right, let's go back to our PowerPoint. So, do gases weigh anything? Well, in that video, we just found out that gases do actually weigh something, because it is a material, isn't it? So let's find out. So if I go back to this, so the red, gases are lighter than air, so they do not weigh anything. Well, I actually think that is false, because we just found out that carbon dioxide is actually heavier. So if we filled a balloon up with carbon dioxide, it would fall to the floor, wouldn't it? Compared to helium, which we found out actually is lighter than air. So when gases are lighter than air, some gases are, but not all. Gas has no weight because it's invisible. I think that's false. Gas definitely does have a weight. And then finally, a gas does have weight because it's a material, and that is definitely correct. Let's see. So this is Maya. She weighed a glass of fizzy lemonade. It weighed 173.1 grams. Gently, she swirled the glass around to make the liquid flat. In other words, to remove the carbon dioxide. She weighed the glass again, and this time it weighed 172.6 grams. The drink was lighter after the gas had been removed. This shows that gas in the fizzy drink, carbon dioxide, does have a weight. So do gases weigh anything? Well, it absolutely does. The glass of fizzy lemonade was heavier than the flat drink because it contained carbon dioxide. Some gases are lighter than air, but some are heavier, and carbon dioxide is heavier than air. So let's have a look at some true or false things again. So look at the statements below and decide whether they are true or false. So I think that we could label this, so number 1, 2, 3, 4, 5, and 6. So instead of you having to copy these out or print this out, instead of label 1 to 6, and you could just put either a T or an F next to these and decide whether you think they are true or false. And then once you've finished, you can come back and then we can go through to see if you've got them right. Okay, so pause. Right, so let's have a look. Carbon dioxide is a gas at room temperature. Is this true or false? Let's see. It is actually true. It is a gas at room temperature, even though that you can't see it. Just like I'm in my house at the moment, carbon dioxide will definitely be a gas at room temperature because I can't see it. Next, gases keep their shape. Is it true or false? This is definitely false. If you remember the particles of a gas, they are definitely not squished together. They are everywhere. They do not keep their shape. They go absolutely everywhere, flying all over the room quite randomly, so they do not keep their shape. Next, carbon dioxide is useful. Is this true or false? I think that's definitely true. We've just said that carbon dioxide can be used in fire extinguishers to put out fires. And it also used in aeroplanes and trains to keep the food nice and cool, so it's definitely useful for us. Next, the bubbles in fizzy drinks are bubbles of gas. True. We've just learnt that in fizzy drinks there are carbon dioxide, and that is how we have Coca-Cola, how we have lemonade and fizzy drinks. Next, gases are lighter than air, weigh nothing. Gases that are lighter than air weigh nothing. Sorry, I think I read that out wrong. Let's see. False. If they are lighter than air, so just like helium, helium still does weigh something. It can't weigh nothing. Because all gases, as a material, it must weigh something. And then finally, you can find the weight of gases. Definitely. In that experiment just before, when they had the glass of lemonade and they shook it to make it flat, we still found out that it did weigh something. Okay. So this next part, this is completely up to you whether you do it. I have got no expectation of anybody completing this because even me, myself, in my house, I wouldn't be able to complete this. So this is just something, if you have the equipment and have the materials to do so, you can do it, but there is no expectations from me to do this. I think just listening to this video alone is sufficient enough. However, if you would like to complete this, this is a comparing gases sheet, and I will blow this up for you on in a moment. So this is where I want you to, using some scales, you can weigh each fizzy drink before, shake it up until it's flat, and then weigh it again, and then compare the difference between the two weights, and then that will tell you how much carbon dioxide is in each drink. So you could do this with a glass of Coke, you could do this with a glass of lemonade, some soda water, some tonic water. You could do this with as many different ones as you can, and to find out the difference between the two, and maybe change up how long that you actually shake it for. Maybe you could shake it for 2 seconds and see how much goes. Shake it for 30 seconds and see how much goes. And then when you've gathered your results, come to a conclusion and see what it goes. Again, there is no expectation for doing this. Ideally, we would be doing this inside the classroom and we would have a really fun activity, but obviously with everything that's going on and we're all homeschooling, this is unfortunately just the way that it has to be. So we're going to leave that there. There will be something on Class Dojo. I'm going to put out a task. This is, again, it is just up to you whether you do it or not. But so well done. So our aims: investigate gases and explain their properties. Success criteria: with the lemonade bottle, definitely identified solids, liquids and gases. You've definitely explained some of the uses, and if you can do that task, I'd investigate the weight of a gas, but again, no expectation. Right guys, well thank you very much for listening, and I will see you in the next one. Okay, bye.